All right. Now, again, if you'll notice here, guys, the first worksheet is worked out for you. So you can go home tonight. If you don't know how to do the first worksheets, the solutions are there. And if you don't know how to do a problem, listen, I really encourage you to go listen to the explanation. All right. But again, I don't think it's that difficult. All right. I don't think it's that difficult. So let's quickly just take a review. All right. If you were to draw a circle, that is called the center of the circle. And then please look up. That is defined as the what? Radius. The radius. Most of you know that. And then if I draw the length from one end of the circle to the other side of the circle that passes through the center is called the diameter. Easy. All right. Now, with a little bit of calculus, all right, in the future, you will be able to prove what the circumference of a circle is. But right now, you're going to have to take my word for it. Now, when we talk about circumference, what are we talking about? All the way around, which is another name for the... No, area is what's inside. The perimeter. So I would say perimeter and circumference are kind of synonyms, right? They mean the same thing. It's just the circumference, all right? The circumference is just a special word for what? The perimeter of the circle, all right? So again, all right, all you're doing when somebody asks you to find the circumference is to take your little guy here and walk around the circle. That's what the circumference is. All right? Anybody have any questions? Now, can anybody tell me, or does anybody remember from last year or the year before that, what the formula for circumference is?
I think it's diameter.
You're 100% correct. Very good. So on your paper right now, what I want you to do is I want you to write at the top of the page, circumference is pi times the diameter. Listen, you're just being distracting. So whatever you're doing, let's get it done so I don't have to worry about you. All right? The circumference is pi times the diameter. All right? Now there is another formula.
There's
all right? It is...
There's the area, which is...
Nope, we're not doing area today, but you're right. That is a formula. The other formula for circumference, you could say circumference is pi times d, or circumference is...
Pi r.
Close. That's area, actually.
Close though. Pi times r plus r.
Pretty close. What's r plus r?
It's the diameter.
R plus r is 2r. You with me? So again, listen. The circumference is 2 times pi times r. Because twice the radius is the what? The diameter. Listen to what I'm showing you up here. Look up real quick. Right? Look up for a second, just so you can see the logic. If that's the radius, this is considered the what? Now, the diameter is always what? Twice the radius. So on my formula, what I can do is I can replace the diameter with what? Twice the radius. That's how we're coming up with this other formula. Is everybody with me? All right. So the formula you have to remember is pi times the diameter or 2 pi r. Does it matter which one you use? No. But I tell kids, use the one based off of the information that is given. So what in the world does that mean? That means, for example, number 1, they give you a diameter of 18 yards. So your job is to write down C equals pi d. That's what you're writing down. Every time you're going to write down the formula, because on the ARBs, they're not going to give you the formula. And so they ask about circumference. If you don't know the formula, there's no way to do the problem. So I'm trying to drill it into your head right now what the circumference formula is. The circumference is pi times d. So your circumference is pi times 18. Now it says round to the nearest tenth. So everybody do pi button on your calculator. I don't want you to do 3.14, even though it really won't make a bit of difference. I'd like for you to get in the habit of using the pi button. And we're rounding it to the nearest tenth. So, Hanson, what's the answer number 1?
It's got it.
56.5. Now, the only other mistake you made,
Wait,
56.5. Is it 6 or 5?
I mean,
Five.
it's maybe 6 because it's 4, 8. The 8 makes the
No,
back turn.
yours
no,
is
no,
nearest
yours is
10.
Yes, to the nearest 10. Hanson, are you okay or not? All right. So it's 56.5 what, though? You have to use the units. And units is just what you're measuring in. And you're measuring in what? Yards. So everybody would say 56.5 yards. All right. Number 2, Cole. Now, this time we're going to use what formula? The other one. So we're going to put down on your paper C equals 2 pi r. Because they give you the radius. All right. So go ahead and put down the 2 pi r.
So you have to do 4 times 4, which equals 16. So 16 times 5.
You mean 8?
Oh, 8. Sorry.
That's okay. No, I know what you did. I know what you did. All right. So tell me what the answer is.
Meters.
25.1 meters. Perfect. 25.1 meters.
Will we get points off of the
Yes, you have to put the units. All right, because we're going to be talking about area, and I need you to know the difference between length and area. All right, Carly, you're up. Number 3, what formula am I using?
You are using C equals pi times D.
All right, so what's my answer?
Answer is pi times 4.2. Oh, yeah.
I need a calculator. Go, get up. Come on, sometime today. All right, you're supposed to bring a calculator every single day. Every single day. Here, use this one. Come on now, hurry up. Tell me what it is. Shh. She's.
What?
Just come on. Tell me what.
It's 13.2.
You may agree with 13.2 meters. 13.2 meters. All right, Allison, what's up? Number 4. What am I doing? What formula? And then?
2 pi times 4.
Okay, now tell me what that answer is. 28.3. Anybody else agree with 28.3 feet?
Yeah.
28.3, yeah.
All right. Radius is 9 3/4. Caroline.
So it would be C equals 2 pi r, and then you do C equals get 2 pi, and then times. I did 9.5.
Yes, I actually prefer that. If you know the decimal, good job.
And then I got 60.
Anybody else get 60.1.3?
61.3,
What?
yeah.
Oh, 61.3.
Yes. All right, let's just get the other Caroline out of the way. Go.
Oh, me? Okay. It'll be C equals pi d, and so it's pi times 6, which equals
18.8 what?
Oh, kilometers.
Kilometers. Good job. All right, William, you're up, buddy. Tell me about number 7.
Number 7. So you would do C equals pi d,
Good.
and then you would do pi times.
Okay, so on your calculator, do 5 divided by 8. I like that.
Oh, 62.
There you go. So try to remember, put that in your desk or in your mind. 2.6.25. All right.
So
And so now tell me what that is.
it is 8.2.
8.2 what?
8. Oh, inches.
Thank you. Emily, I skipped you, right?
Mhm.
All right, you're up. Number 8.
So it's pi times b and then
Whoa, 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 whoa. Pi times what?
times
What are we given? What are you given on number 8?
oh, a fraction.
The radius.
Oh, so it's 11
What
and
formula am I using?
pi times b.
No, because they give you the radius. True?
Mhm.
So we're going to use the one with the radius in it. What formula has the radius in it?
It's pi times radius.
Or, come on, this is what I want you to say.
Alright.
2 pi r. I mean, radius plus radius is 2 radii, right? So it's not wrong, but we don't say that. We just say circumference is 2 pi r. You with me?
Mhm.
All right, so now let's go back down. C equals 2 pi r.
And
Are you going to do the decimal or are you just going to type it in as a fraction?
I'm just typing.
Good job.
And so then it's 22 3/8 times pi.
Yes, I'm okay with that. However, I want you to just go ahead and round it to the decimal. So is that what your calculator is doing?
Oh, 70.3 cents. That's what I got.
70.3 centimeters. Thank you.
Yeah.
Now, are you good with that? You understand that, right?
Mhm.
All right, now remember, as I was fussing with my last class, man, you can't wait till we get to 20 before you say, hey, man, I have no idea what we're doing. All right, anybody have any issues? Any issues? Yes, sir.
Then I got 72.2. I think
You got 72.2?
yes.
Did everybody else get 70.3?
Yes.
So then do it again.
I got 70.3.
Oh,
2 times pi times 11 and 3/16. Try it again. I want to know if you're making... the main thing is now, believe it or not, trying to teach how to use the calculator. Or that's important. All right? And if you're not coming up with the right answer using the calculator, I got to teach how to use the calculator. Is that good or not now? Now remember, when you're typing in a fraction, you can just hit the ABC button. You good now?
yes.
Okay, good. All right. Now, I don't care about the matching here. Does everybody understand that? We're just going to tell me what the answer is. Over here, Kate. Number 9. What am I doing? What's the formula?
C equals 2 pi r.
Good. And so? Anybody else get 53.4?
Yeah.
All right. Catherine. Number 11.
Okay.
What formula?
So it'll be C equals pi d.
C equals pi times d.
So I got 28.3.
And then, does everybody understand why they're putting units down?
Units.
Because they didn't give you a specific length. Inches, feet, yards. All right, Alex, help me out, buddy. What am I doing for you on number 11?
Alright, but I'll do C equals pi times
Beautiful.
pi times.
Yes, sir. And tell me what that is. 20.3? 4? Is everybody happy with that? Is that about right? 20.4? All right, Miles, 12.
Number 12, the radius is 12 units. So you would do, 2 times pi times 12.
Right. Tell me what that is.
Let's see. 75.4.
Anybody else get that? All right. Everybody agree that's not that hard, right? All right. Now we're getting the word problems, which generally a little bit harder. All right. So now here's where I need everybody to understand something. Look up, please. For whatever reason, I don't know exactly why, but this is a hard concept. All right. Please look up in my explanation. Look up. So it's very easy. All right. So I am going to. Some of you aren't looking up now. Hello? I'm right up here. Look up so I can show you something. How obvious. I just made one complete what?
Circle.
One complete rotation. Right? One complete rotation. Right? If I decide to do this, I'm just going to continue on with a second rotation. Everybody agree with that? So rotation, if I were to ask you to measure the rotation, all I'm doing is I'm measuring the what? That's right. The perimeter better is the circumference. All right, is everybody with me on that? So if you get on a giant Ferris wheel and you want to figure out what one rotation is, all you're doing is figuring out what the what?
Circumference.
All you're doing is figuring out what the circumference is. And the circumference is a what? Is a length. All right? Now, it doesn't look like you're going anywhere if you start here, right? If you're starting over here and then you walk around the circle, it doesn't look like you went very far. Right? But you have. All right, you've traveled one circumference. One rotation is one circumference. All right, now why is that helpful? Because when you ride in a bike and you travel down the road and your tire rotates 10 times, that means you have traveled what? How far have you traveled? If your tire goes around 10 times, how far have you traveled down the road? You've traveled 10 rotations, which means you've traveled 10 what? What's a rotation again?
Circumference.
Yes. So to figure out how far you've gone, you would figure out what the circumference is, and you would multiply it by what? 10. Is everybody with me? All right, so one more thing up here. Look up, please. Look up. If I'm going to figure out how far, what I'm trying to get you to do now is I'm trying to get you to visualize something. So look up here. Even though I'm not very good at it, I'm going to give it a shot. I'm going to slice that circle right there, and then I'm going to lay it out. That length right there is the what? It is the circumference. All right? If I were to cut it right here, and I would take this, and I would lay it out flat, that's the circumference. Is everybody hearing me? And that rotation, all right, is what they're asking you about. All right, so there is what's referred to as your linear distance that you have traveled. Does everybody understand what I'm getting at there? All right, so instead of walking around the circle, if you've walked around the circle, it looks like you haven't traveled anywhere. Right? But what you're doing is you're actually walking, all right, the circumference. That's what I'm trying to show you. All right, that's really important. All right, especially when you get later on, all right, and you start talking about science, all right, and different things. All right, very important. All right, one rotation just simply means one circumference. All right, so now with that in mind, let's see if I've done a good job explaining things. All right, so what we're going to do is we're going to look at number 13 now. It says a baseball has a radius about 1.5 inches. Home plate is 16 inches wide. If a baseball were rolled across home plate, how many complete rotations would it take to cover the distance? All right, so let me see if I've got this correct. All right, so here we go. I know some of you don't know baseball, but do you remember in your baseball, all right, this kind of looks like home plate for whatever reason. I don't know why, but that's home plate.
Yeah, it kind of
All
looks
right,
like a house.
kind of looks like a house. I don't know what they were thinking of when they decided to make home base. All right, take it to the house, right. So then we have a baseball. All right, so I'm going to draw this baseball. And of course, you're going to easily be able to see my three-dimensional effect there.
Oh, yeah.
All right, obviously, right? So there's your baseball. And your baseball has a radius of what?
1.5 inches.
So your baseball has a radius of 1.5 inches. All right? So now, if you'll notice, it says that home plate is 16 inches wide. So this right here now is 16 inches wide. I'm going to pick up this baseball and I'm going to move it right here. And I'm going to roll it. And I want to know how many times the baseball rolls to get to the other side of the plate. Who wants to tell me? Good. How many? 5.3. I'm kind of impressed there. 5.3. Anybody else want to see how many rotations that baseball is going to make? Good. What do you think? I've got 18 point what? 8. Good. What do you got?
10.6.
Wow, 10.6. What do we got here? Somebody said 1.7. That's kind of funny. Somebody says 10. Somebody says 1.7. Someone's way off. All right, somebody is way off. Hanson, of course, is going to tell me the right answer. Go ahead, Hanson. I put 5.3. Okay, good. I've got 2 answers for 5.3. Wow. Wow. Okay, so I'm kind of impressed. All right, so now, listen, what I'm not sure if you're quite understanding what I'm saying is, all right, I want to know how many rotations it's going to take for the ball to get to the other side of the plate. Is everybody with me? Right, so my question is, if the baseball has a diameter or has a radius of 1.5, what would its diameter be? What's the diameter? 3. So the circumference of the baseball would be 3 times pi, correct? So the circumference of the baseball is what? 9.4. Now stop embarrassing me. How many times is that going to roll across?
1.7.
You should be able to look at it and say, I know it's somewhere between what? 1 and 2. Right? Now, because we don't know, we're taking the total distance, which is what? 16 inches across, and we're going to divide it by the circumference of the ball, which was 9.4, and now you're going to tell me that's what? Good. Those of you guys who said 1.7 times, you can pat yourself on the back. You understand everything there is to know about circumference. Everything. All right? It's not that difficult. However, listen to what I'm saying. If you're trying to convert a circle into a length, you must find its what? Circumference. So when you get on your bike and you start traveling down the road, all right, every time your tire makes a rotation, you're moving the what? Circumference. That's what you're doing. All right, so I need you to think of the circumference as a length. All right, circumference as a length. And anytime somebody says to you 1 rotation, you're supposed to remember 1 rotation is simply 1 circumference. If I say 5 rotations, you're going to tell me that's just the length of 5 circumferences. All right, that's it. All right, so now let's take a look at 14. A soccer ball has a circumference of about 28 inches, while the goal is 24 feet wide. How many soccer balls would be needed to cover the distance between the 2 goalposts? Whoa, 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 whoa. Now you got to listen on this one now. Again, hear me. These are the good thinking questions, trying to get you ready for ERBs. Please think about this. And I always tell kids the reason I'm good at math is because I used to not be very good at drawing, but I could sketch my thing, sketch each little drawing out. It makes it so much better. All right, it makes it so much better if you can sketch this out. So if I walk around and you don't have a drawing, you're probably not going to get the correct answer. All right? Now, somebody want to give a stab at it real quick. Oh, no, but I want to know what the answer is.
Okay.
I want to see who's got the answer.
Alright, so let's see circumference.
Shh. Tell me the answer. Somebody.
Alright.
Everybody's familiar with my soccer goal, right? And it's how wide? It is 24 feet wide. Now, what's the problem right off the bat? I have feet and inches, right? So I'd want to figure out, let's convert to the same units. So I would convert that 24 feet is the same as, I think 288 inches. Double check me.
288.
24 times 12, 288 inches. Does everybody agree with that?
Yeah.
Come on now.
Yes, sir.
All right, so I'm going 28 inches. Now, the circumference, it says, of my soccer ball is 28 inches. So if the soccer ball is 28 inches, the circumference, all right, then look what I'm trying to draw here, guys. So you understand what I'm doing? I'm trying to figure out how many soccer balls line up against the... Does everybody agree with that? Right? So how many soccer balls fit there? Well, in order to figure out how many soccer balls there are, I have to figure out what? What do I have to know? I have to know the what? Yes, you have to know the diameter. Why do I have to know the diameter? Because that, all right, if I line all the soccer balls up next to each other, all right?
I thought we needed to know this.
Yes, we do.
But they give us their circumference.
They give us the circumference.
Oh,
So
you need to find the diameter.
Oh.
So listen to me though. Here's one way of doing it. If I take the 288 inches, all right, I'm trying to get you to visualize this right here. Look up, please. Come on, because it's kind of hard. All right? Does everybody understand? I just visualized that, right? Now, do you understand that the circumference is different than the diameter in this case? But does everybody understand how the diameter is more important than the circumference? Does everybody agree with that? Right? Is everybody happy with that explanation? So if the circumference of the ball, what is the circumference?
It's 28 inches.
That's all right. That's all right. The circumference is what?
28 inches.
28 inches. If the circumference is 28 inches, then what's the diameter of the ball?
It's 8.9.
Right.
Somebody said 8.9. Do you agree?
1.9.
So the diameter of the ball is 8.9 inches. Now, how did I know it was 8.9 inches? Because we did a little algebra. All right, so what did we do? We said 28 is equal to pi times the diameter. So everybody is supposed to say, well, that's obvious. I just divide both sides by pi, and that will tell me the diameter. And that will give me 8.9 inches, roughly. So how many soccer balls fit across the goal?
32.
Do you agree with that? Do you agree with that? How did I know it was 32.4? Because this length from here to here is 8.9. How many 8.9s are there in 288? So you're supposed to take what? 288 and divide it by 8.9.
Oh, I see.
And that should be what again?
32.
About 32.4. So you could fit comfortably 32 soccer balls along the goal. All right, so kicking the soccer ball into the net doesn't seem like that hard of a task if you can fit 32 of them in that area. Right? And if you want to measure up this way, how tall it is, man, that's a lot of space to kick that little ball through. Right? I'm not sure why it's always 1-0 or 3-2 or 2-1. All right? But anything, I don't know anything about soccer, so, all right. So again, is everybody okay with that? That's hard. That was hard. All right, but I drew the picture out. If you draw the picture out, I'm telling you, it's easier to get better. All right, quickly, I'm listening.
How do you know to do like 28 divided by 5?
Well, because you see what I'm saying? I have the circumference. So now watch what I'm trying to show you right now. You ready? I'm trying to make this. So this right here would be considered like the circumference. But I have to translate that circumference into a diameter. Because I don't care about the circumference, I care about what? The diameter. You with me on this? Okay? Well, because I used a formula. Good. Watch. That's another good question. You ready? Circumference is pi times the diameter. They gave me the circumference was 28. So 28 equals pi times d. Do you understand that? So all I did was I divided by pi.
Oh, okay.
Right? And that gave me that answer. All right. Very good. Thank you for asking. Important. Very important. All right. Now let's try 15. All right. Chariot races reached their peak in popularity in ancient Rome around the 1st and 2nd centuries. A chariot wheel had a radius of about 1 foot. One lap around the track was 2,300 feet. How many chariot wheel revolutions did it take to complete a lap? Now look, everybody should get this one right now because I've done another fantastic job today, so this should be pretty easy. All right, so I want to tell someone, tell me how many rotations did the wheel make to get all the way around? How much?
365.1.
365?
Oh, I put.
No, he could be way off.
Well, I
I wanna know what you hear.
1,100.
1,100.
I got 444.
Oh, wow, these are all good. See how good I did today? 365. Anybody else? Come on, Ben. Still working. Hanson, you still working? What about you? Girls, come on, give me an answer. You're always right. Tell me. Well, let's go. Emily, still thinking. Allison, come on, girl, draw it out. Let's go. Come on, chop, chop. What is the answer?
I'm still working.
Oh, my goodness. Come on, girls.
I got 365.
365. Uh-oh.
But it rounds to 365.1 because the 7 before the 0.
How much?
140.
144. Nice. I'm not saying that's correct because we have this one right here. I don't know is not an answer.
No, that's the
That
correct
is
answer.
brilliant. Here we go. Look, I'm moving this out of the way for this moment. All right. Now, again, listen to me, guys. All right. So the length of the field is how many feet, guys? Come on. This is embarrassing. The length of the field is how much? 2,300 feet. So just visualize from there to there is 2,300 feet. Here's your big chariot. Here's your wheel right there. What's the diameter of that wheel? 1 foot is the diameter. Does everybody agree with that?
No, that's the radius.
Uh-oh, somebody's told me no.
Yeah, 1
Yeah,
foot
it's
is the radius.
That's what I said. 1 foot is the
You said
radius, so the
diameter.
diameter is
Mr.
what?
Right back up.
The diameter is what? The diameter is 2 feet. The diameter is 2 feet. Does anybody have an issue with that? So, if the wheel turns around 1 time, how far down the road is it?
Or
No.
What? It's
What is it? If I wrote, how much? About 6.3 feet.
it's like,
Right? Because circumference is equal to pi times diameter, which again is roughly 6.3 feet. He said 6.28. I'm not arguing. All right, is everybody happy with approximately 6.3 feet?
Yeah.
So if one rotation is 6.3 feet, how many rotations is it for 2,300 feet? Now, because we're brilliant, we know we can just do what?
You can just do 2,300 divided by 6.3.
Yes. 2,300 divided by 6.3 equals
365.1.
365.1 rotations. Now listen to me, and I keep telling you this now for half a year and a little bit more. You can't get any smarter if you're not trying. If all you're doing is writing down my information, that's not doing any good. Like I said, I'd much rather have somebody tell me 1,700 is the answer than just write down 365.1 because I told you that. For that's of no value. You're not going to get smarter taking the ERBs if you just let me tell you everything. You've got to come to something that's a little bit uncomfortable, like that problem is difficult. It is not too hard to solve. Right? You're not going to get any better if you just let me tell you what the answer is every single time. Draw it out like I'm doing. All right, it's very helpful. It's very helpful. And the other thing, some advice would be ask me a question if you're not sure. Ask me a question if you don't know where I got 6.3 feet from. Or ask me, why did I divide? I can draw it out and show you. What?
Okay.
Everybody's okay with that? All right. Now, again, I'm pretty happy with you today. All right, pretty happy. So listen, the ERBs are important, so I want everybody to try 1 through 5. And then I'm going to give you a break up here. All you guys have to do on the first worksheet is the what? Yeah, that's it. I'm going to give you a little break on this. All right? Now, those of you guys...
Whatever means you practice more than you.
Yep. So, again, it doesn't matter. It doesn't matter. I do want you to write down the formula. Circumference equals pi times d or 2 pi r. They simply are not going to give you the formulas for the test. So you're at a huge disadvantage if somebody asks for circumference, you have forgotten what the formula is. So tomorrow when I check your work, I'm not going to be happy if you don't have the formulas written down. Every single time. If they give you the radius, you put 2 pi r. If they give you the diameter, you just put pi times d. Now I'm letting you use a calculator. All right? So that's in exchange, all right, for doing it without a calculator. Write the formula. The formula is more important. I know you can multiply decimals, so it's not an issue. All right? So we're doing the odds on the first one. You hear me? We did the second page. And now I want everybody to try 1 through 5. Now, if you look at number 1 and say, I can't do it, that doesn't mean you can't do 2, 3, or 4, or 5. Read them all. Write something down. All right? Get some work done. Try it. All right? That's how you're going to get better. Plus, I want you to be really happy with your ERBs this year. All right? Much improvement is coming if you do this work that I'm asking you to do. Now, finish up.